All right, I think I'm just gonna, I know it's a minute earlier than it usually is, but I'm just gonna get started because I kind of have a lot to do today. And if you're just coming in, maybe make sure you grab a copy of that practice exam. I have lidded hard copies available, so hopefully you can get a copy of that. I don't think we'll run out based on my assessment of attendance here in the early going first couple weeks of class. Yeah, sure thing. Okay, so my plan today is to kind of continue on a theme that we've been talking about, which is interference with markets, right? And some of the things that can happen, for better or for worse. We've talked about price floors and price ceilings. I'm going to get back to that in a second. And then we'll segue into this discussion of taxes and tax incidence. By the way, one of the reasons we do this is because the tools that we'll talk about here with taxes and tax incidence, it's kind of a useful general way of thinking about what happens when you intervene in a market. And we'll be using these ideas throughout the course of the semester. So we are, this is kind of into chapter 8, which talks a lot about market interventions. And I think I know that is it for the exam. Chapters 1 through 8, there are now, let's see, I guess this kind of summarizes the schedule here. Here we are today, lecture 7, and as predicted, right, as the prophecy suggested, I did hand out some practice materials. More on that in a second. So 1 week from today, we'll have our first exam. And it'll look almost exactly, not exactly like what you have in your hands here, the practice exam, but the same length, same set of ideas on there, all of that stuff. So you can do these practice materials. If you want, you can figure out how to upload them to Gradescope, right? If you remember that first attendance exercise we did. And then I can take a quick look at it before our class Thursday, where we will just go over all the practice exams, right? Go over practice materials. So the other thing that I did is there's a copy of this thing on Top Hat as well, right? This exam, if you want to download it and try it again or whatever. But I also made, I had some extra questions laying around in my test bank that I haven't used. So I put 36 of these questions up on Top Hat in online form with a little bit of a time thing on there. So you have this 2-hour kind of, extended test. If you want to take a stab at it, you can give it a try, and I can grade it for you. You can do it again. But the same type of questions are here that might, just additional review stuff. Students like to have questions. And so I just tried to give you as much as possible to practice. And that also gives me more stuff to go over for our big review next class, where I'll just kind of talk about all the materials and all of that, all of the practice materials. Okay, 2 other things. I sent out an email just reminding you that the exam is next week at this time. You'll just come to class, take the exam, and then leave, whatever. But I also sent out a nudge email. I kind of went through all of the Top Hat grades just to see, who had done what. And if you're kind of, it looks like almost all of you, by the way, especially people who are here today, are pretty well caught up on the stuff. But if you aren't, I just kind of gave you a nudge. And maybe if you fall into that group, you can just fire me an email and say, oh yeah, I know, I've been busy, I'm getting to it. Question back there. No, the exam is on paper. Right here in this class, a week from today, right? Good question. And of course, we have one more class, the review class. I'll talk about, things you can and cannot use on the exam. And so we can do all that next time. Yes, another question.
Will there be room for extra credit prior to this?
You know what? We'll worry about that after. Well, part of it, I'm sort of thinking, we had a weird February. There's bad weather. We missed a class here and there. And I was saying maybe I should, and I'm just like, let's just get on with it, At some point we just need to throw down a benchmark and then we can start thinking about other things. But that having been said, I'm trying to get everybody kind of on the same page and get the homework done and all of that. So, okay. All right, so I do have my office hours there, and we also have our TA, Daniela, who is available at other times. I've discussed with her that maybe students don't like the fact that Baker's, here early and kind of leaves a little early too, by professor standards. So you can contact her if you need additional help. Okay. Yes?
So, saying that if you want this gradient to upload, you mean how?
So if you do it and you say, hey, I'd like to upload this to Gradescope and have you look at it before Thursday's class, hopefully because of my first attendance exercise, maybe you got a notification from Gradescope. If not, let me know. You can fire me an email or something and say, hey, I'd like to upload it, and we'll figure it out. But yeah, it's not, you don't have to do it. By the way, all of the practice materials are optional. You don't have to do them. You don't have to hand them in. They're just for you, and depending on how rigorous you want to be with getting things checked and graded ahead of time and all that. Okay. So anyways, back to the lecture at hand. This is our vision of a market and how it works and what it does, right, to date. So just remember that the demand curve encodes information on value. The way we say that is that demand reflects marginal benefits of each unit produced, right? The additional benefit that each unit consumed, I should say, gives someone. Supply encodes cost information, as we say it, marginal cost information. The cost of each additional unit produced, given we're producing a certain amount. It goes up because costs increase, right? The principle of increasing costs. Equilibrium is where the two curves cross. That's where plans are consistent. Everything that is produced is consumed or purchased by someone. And then if we want to recover total benefits, right, total gains from exchange for consumers, well, that is consumer surplus, the area below demand yet above the market price. What that means is people, when they buy things in a market, typically pay less than they value something at, right? And consumer surplus collects all of those differences, what you would have paid versus what you actually paid. Same is true for suppliers, right? Producer surplus, the blue triangle here, everything below the $10 price, yet above the supply curve, that's the difference between what a producer would have taken minimally to produce something and what they actually get in the market. Add those two up, we call it societal welfare from the market, or if you prefer, the total gains from exchange, right? Who would have thought so much information in a simple X diagram, right? Now we talked a little bit about what happens when you interfere in markets, right? By interfere, what we mean is we try to do something other than what the price is, right? There's this thing called the equilibrium price. For whatever reason, maybe we want to, if you're just coming in, you might grab a copy there. We may want to try to, say, legislate a different price because we feel that the price is too high or too low, right? So it's a little hard to read here, but the two biggest examples of this are, rent control is one example of price interference, and minimum wages are another, but there are a lot of others too, right? General price supports, ceiling. We call these things ceilings and floors. This slide tells you something about how a ceiling works, and you can sort of focus in on the geometry here if you want to know what the practical aspects of it are. The ideas are that, well, we want a price lower than the going market price. So in my example, we have a ceiling here. The typical market, the market price would be $3,000 in the upper left diagram here, and 600 units of the product would be exchanged at this market equilibrium. Suppose we feel that $3,000 is too much, right, for rent. That's typically how the argument goes. We pass a law that says the price cannot go above $2,000, right? That's what the dark line is there, where it says rent ceiling, or price ceiling generally. Notice it's below the equilibrium, so it keeps the market from drifting up to the equilibrium value, right? So we notice also that at this rent ceiling price, there is a shortage. right? That is to say, more people want housing or rental housing at this price than suppliers make available. In fact, you can actually see what the shortage is. 800 units are demanded, only 400 units are supplied in my example. So we would say there's a shortage of 400. Now, we can actually calculate out all the surpluses as we would before, right? So geometrically speaking, the object down here, purple, is producer surplus, right? We stick to the same rules. Everything below price, but above the supply curve. So what is that area? Well, I like to have these examples simple enough so I can do them in my head, right? It's a way of checking that they're exam ready, say. Let's see, if we turn this way, we could say the base is 2, right? And the height is 400. So 2 times 4 is 800. Divided by 2, that's the area of the triangle, right? Gives us 400 for the purple area up there. So maybe I can just do that out. All right, I'll just do 2 times, I know the numbers are a little small up there, divided by 2, and that gives us, well, 400 as producer surplus, right? Consumer surplus, right, is the red area, everything that's shaded in red up there. But this is consumer surplus under the best possible circumstances. I'll get to that in a second. This is how I might have you calculate it on an exam, right? That would be, let's see, well, you could use the area of a trapezoid, but that's too difficult for the likes of me. What I would do is break it into a rectangle and then the triangle on top, right? So you see the rectangle there, the base, or the, I guess I could say the height, 4 minus 2 means it's 2 units tall. It's 400 units wide. 2 times 4 is 800, right? So I could go 2 times 400 equals 800, right? And then 6, the little triangle above that, 6 minus 4 is 2 times 400 again, divided by 2, that will give me 400 as well. So we have to add that in, 2 times, I know this is a little hard to read, but. So we would say that total consumer surplus in this best case scenario is 1,200, right? We could add all of that up, and that would give us $1,600 in total gains from exchange. You'll notice that we have this gray triangle there. What is that? Well, we think of that as the deadweight loss, right, that occurs from our intervention in the market. That is to say, these are gains to exchange that don't materialize, right, because of our rent ceiling. That is to say, these are units that someone would have paid for at the going market price and someone would have supplied, but they're legislated, in effect, out of existence. And you can calculate out that area of that deadweight loss triangle and get a dollar figure for that as well, right? So if I turn my head this way, we can see that it's a triangle with a base of 2, and the distance from 400 to 600 here is 200. So it would be 2 times 200 divided by 2, right, which gives us 100 as the deadweight loss.
And deadweight loss is measured in dollars.
Yes. Incidentally, I'm glad you mentioned that, because one of the great things about all of this is that at least 2 of these things, right, maybe all 3 quantities, are not obviously measurable, right? How do you measure the gains that people get from buying something, right? How do you measure what is this quantity that we don't actually observe traded in the market that we've lost somehow, right? Trades that don't materialize. How do you measure that? We're able to measure all of these. One other thing I might say, maybe being a little provocative here, maybe in anticipation of the exam, I've kind of jumped to just calculating out all these areas, right? Red, blue, gray. But as an economist, you should almost never proceed this way, right? You don't draw this diagram first and then just start, calculating areas. What you usually want to do is start by thinking about what the world would look like if you had no market intervention, right? Remember, start with the counterfactual. In which case, what we should have done is we could have said, well, let's see. If our market was functioning without intervention, 600 units would have been supplied at a price of 3. We could then calculate out the consumer surplus as the triangle above the market price of 3. In fact, 6 minus 3 is 3 times 600 divided by 2. What is that? 6 minus 3 times 6, that's 6 times 3 is 18, divided by 2 is 900. Yes? Okay. And I think for producer surplus, we'd have the same thing, right? Maybe I can just use this diagram. 3 here, 6 here. 6 times 3 is 900, right? For producer surplus. And then we can say that our total market without intervention would have given us $1,800 in gains to exchange, right? So another way of thinking about what the deadweight loss is, well, we could have, did I do that right? I feel like I got somehow the wrong answer here, because I did this wrong. Okay, it's good I checked. Note to yourselves here, right, that you can always check your answers here. So I'll show you where my mistake is in a second. You'll notice that when I calculated out surplus over there, upper left, for producers it was 400. Consumers got 1,200, right? And if I add those together, we get 1,600, right? And then I calculated out the deadweight loss triangle, the gray. Well, that was 2. I said 100 here. This should have been 200 though, right? So that should be deadweight loss of 200. I messed that up. How did I catch my error, you might ask? Well, I was looking at my example when I said, well, what would have happened if there was no market intervention? And so there's 900 in surplus, 900 produce surplus, 1,800 total. The difference between the two should have given me the deadweight loss, right? 1,800 and 1,600. But mine was 100, so it was wrong. So the beauty here is there's multiple, because of the nice geometry of the problem, there's multiple ways to calculate all this out. Okay, yes?
When finding the base in the triangle, you just count how many units I itself, for example.
That's right, yeah. Yeah, so I usually say, well, it's, 6 minus 4 is 2, but you could do that too. You could just go 1, 2, and that's what I've been calling the base. Incidentally, you could also call this the base, and this the height, right? It doesn't matter.
How do we know when to basically break up the triangle? Is the rectangle or the other triangle? Is that just
Up there?
Yeah.
Well, in that case, if you look at your exam, there's a question about, we'll talk about this more next time, but it's just kind of the, wherever the rent ceiling is, you have to sort of go up and to, figure out the geometry based on that. And also figure out how to get the market equilibrium. So you'll get some practice with that on the problems. Yes?
So all the shaded area is the total surplus?
Yes, exactly. Right. And so, you sort of have to, if you think about it as an accounting exercise, when you put the rent ceiling in place, you have to sort of account for it, right? That's kind of what we're doing, is we're saying, here's the equilibrium without intervention. I apologize if that's off the, here's the equilibrium without intervention. These are the total surpluses. So then when we have intervention, we have to sort of account for all of the aspects of the surplus. That's what the deadweight loss does, I guess. It's kind of the accounting discrepancy, if you want to think about it that way. One other thing, though, you'll notice, you might say, well, why did you draw 2 diagrams here? Well, I slid this past you when I discussed the top case. I said, well, this is the best case scenario, right? It so happens that there's no guarantee that the people who value the apartments the most are those that actually get them, right? Under the rent ceiling, right? Because we saw that there's 800 people demanding units and only 400 available. how do we know that the 400 top valuers get the apartments? We don't. Well, this diagram suggests that maybe there's more to this deadweight loss than we thought about, right? Think about some sort of scramble to get the 400 units. Maybe there's a line or a queue or kickbacks or whatever. Well, these people here on our demand curve along here, they're willing to spend up to this amount, right? They're willing to spend, well, the rent's $2,000, but they'll go up to $4,000 in total resources to get an apartment. How do they do that? Well, they could do exactly what I said, spend the extra $2,000 on a kickback or whatever, or they could stand in line or wait or do any number of things to, favors, who knows, to get an apartment. And that would be you could say that then this is also sort of lost resources. Yes?
How would you represent a shortage on this graph?
Good question. So we're getting all the details out here. The shortage is simply the fact that at this price of 2, right, this is demand and this is supply, right?
Okay.
And by the way, it's interesting. I think about this all the time because you routinely, one of the things that happens in markets is you only observe quantities and prices. You don't observe the actual curves without some technique. But you do hear people talk a lot about shortages. There's a housing shortage in New York City, for example. And I sort of wonder, what people mean when they say that. But anyway, go ahead. You were gonna.
When you rent ceiling, if the supply quantity was, since it's less, it's a surplus, right?
This is a shortage.
Oh, it's a shortage.
Yeah, demand is larger than supply.
Less than demand. Okay.
Yeah, it's great. I like all your questions because they're about the details here, and
I'm just trying to make sure I understand everything.
I appreciate that. That's the way to think about all this. There's more moving parts than you think. Price floor. Okay, well here we kind of flip everything over, and if you sort of get what's going on with the logic of our rent ceiling, it's kind of the same thing. So here now we think of the classic example is a minimum wage, right? The way we think about this is we say, okay, well, let's see, maybe we feel like the market wage is too low, so we maybe pass a law that says the market wage should be higher. Fine, okay. What does this do? Well, in terms of the surpluses and all that stuff, I have my top diagram, which kind of parses all of this out. You know what I'm going to do? Oh, God, what happened? That wasn't what I had in mind. That's not what I had in mind again. This is what I had in mind. Okay. So we see here that our minimum wage, our market wants to go to $10 an hour, and at this point 2,000 workers would want jobs. But when we put our minimum wage in place of $15 an hour, you can see kind of what happens here is we wind up with this many people, this many jobs being provided. So one thing about this curve is you have to think about who demands labor. That's businesses, right? That's people that want to hire workers. And at this wage of $15, we only have, let me see what those, I can't read the numbers there. $14.50, is that what that is? See, this is a bad example, but we only have 1,450 workers demanded, right? Meanwhile, 3,000 people want jobs, right? So we have a surplus, I guess, of labor is what you would say. More people are supplying their labor to the market than are being hired into jobs, right? And of course, once again, you can see the size of this surplus just by looking at this. Now, we can do the usual things, and we can calculate out all of the surpluses, right, in the usual way. But one thing we might want to do is just start with my benchmark the way I'd like to start and say, okay, well, let's think about what was happening in the market before any intervention. Producer surplus would have been, let's see, 2,000. This is 10. So we'd have 2,000 times 10 divided by 2 would be 1,000, right? Did I do that right? I hope I did. So in this case, 2,000 times 10 divided by 2 is 10,000. That would be producer surplus without intervention. And then consumer surplus without intervention. Well, let's see. It's 30 minus 10 is 20 times 2,000 divided by 2. So this would be 2,000 times 20 divided by 2, which is 20,000. You add those up, and we would get 30,000 in total benefits in the market, total gains from exchange. So as is usual, when we come along with rent control, we change the distribution of the benefits, right? So, I mean, one thing I didn't mention about the previous example was that you could say that renters, more on this in a second, gained in that there was more surplus going to renters than prior to the policy. So here we put in the minimum wage, and now if we want to calculate out producer surplus, it's this, right? This crazy shape. And it's a little bit complicated. I believe this is 7.5, 1450. Mental note to self, Baker. No examples like this on an exam. I don't want you to have to waste time calculating, but we could figure that out using all of this, using the usual techniques, this rectangle and this triangle. I'll do it in a second. And then we could figure out consumer surplus up there, which goes to people hiring workers. So, yes?
When again, how do you know there's more jobs supplied than demand?
If you look at if we take this to be the price, right, the wage, supply is over here, right? So this amount of jobs are supplied, or this amount of workers want to find jobs. It's, what is that number? 3,000? Whereas demanders only want this amount, right? So that is 1,450. Okay?
And how would this change if the line was below the equilibrium?
Well, then it wouldn't change anything, right? Because the market would just be able to go to its natural equilibrium. So that's another good point, right? That these we're trying to depict effective price floors and ceilings. So an effective ceiling has to go below the equilibrium, an effective floor has to be above it. So if I wanted to calculate out those two quantities here, let me do it this way. We would have 1,450 times, I already forgot what all the numbers were. 1,450 is the times 7.5 divided by 2 plus 1,450 times 2.5, and that should give me 906.2.5, right? What is that? And I'll tell you where I get. That's this area down here, 906.2.5, right? How do I know that? Well, I took this to be 7.5, the base, this to be 1,450. 1,450 times 7.5 divided by 2 gives me this triangle. I messed this up. This should be 7.5 times 1,450, right? Because 15 minus 7.5 is 7.5, 1,450. So I screwed that up. This should be not 2.5, but 7.5. I don't know where I got that. And that gives me 16,312.5. The top triangle up here, after the minimum wage is put in place, is, let's see, 15 tall and 1,450 long. So this is 1,450 times 15. Gives me 21,750, right? So 16312.5, let's see, $38,062.5, that's total benefits. It's funny, the fall of Constantinople comes up there. That's total benefits on the left here. Well, we calculated them out on the right. They were 40,000 total, right? I'm sorry, we calculated them out at the going market equilibrium without intervention. So if we wanted to, we could calculate out the deadweight loss, which should be, let's see, this was, where do we get it? 40. Should be 1937.5, right? I know I did that weird, but it's just so I didn't have to get rid of any of the numbers. Now, so that would be the area of the deadweight loss triangle. And of course, I got to keep moving, but you could check that if you wanted to just look at the, by calculating out this directly. So maybe I'll do it. Geez, it's 550 that from 2000 to 1450 is 550 here, 7.5. 550 times 7.5 divided by 2. 550. Times 7. Is that what I said? Okay, so somehow I didn't get. I should have gotten the same answer. What did I do wrong? 7.5. Oh, 2014. That's 550. I don't know. I'll have to check it. But you should get the same answer doing it both ways there. It's kind of a lot of calculating. See, this is why you got to keep those numbers simple. Okay, so just a couple of things to, and by the way, I could also mention that you can apply the same idea here, that those people who really, or those businesses who really want the jobs, right, or really want to hire people, well, what they can do is, they can, or people who really want the jobs, I should say, they can, engage in measures to get those jobs as well, right, like maybe work overtime or work for free or kickbacks, or whatever. And that would be the total green box then, you might sort of say, would be dissipated there. So anyways, maybe what I'm trying to emphasize here is you really have to think about these things. When you have a ceiling, you create a shortage. And when there's a shortage, you have to ration, right? That is to say, who do you give the apartments to, right? With the minimum wage, you also have a rationing problem, right? Good jobs become scarcer. Everybody wants a good job. So in some ways, a surplus is kind of the opposite of a shortage. And so you have to think about this. How do you allocate those jobs to people? Who gets the minimum wage jobs? And then you might also ask who is most likely to lose a job, right? So the evidence, which I'll talk a little bit about, says, yes, when you have a minimum wage, you do get higher wages. Workers become less likely to move around, right? But some jobs are lost, and oftentimes even total employment, right? That is to say hours worked times people goes down. Evidence also suggests that when we put a rent ceiling in place, well, rents go down, not surprisingly. Tenant stability rises, so people become a lot less likely to move. We lose apartments in the long run. That is to say, supply does fall. And there's also this other dimension, which is that typically the quality of housing falls as well. So you can even parse this a little bit more into, who wins and who loses from these policies. Every policy creates winners and losers. So who wins? Well, rent control, you're a winner if you have an apartment, right? You're a loser if you're a landlord, obviously, right? But you also could be a loser if you're looking for an apartment, right? If you're trying to move into the city because they're going to be exceptionally scarce. Maybe you can find one, but it's harder. And then, of course, there are these long-run aspects. Minimum wages, same sort of thing. Who wins? Those who have jobs. Who loses? Well, those who are trying to get a job, right? Those who are in the, and typically, these are, if you want to think about who gets fired when the minimum wage comes along, it's typically teenagers, right, who are trying to just break into the job market, maybe just want to get some work experience, and also maybe senior citizens. So all those greeters at Costco or Walmart, they get fired. In the long run, it's also been suggested that, there's a reason why all those kiosks have popped up at all the fast food restaurants all over the place, right? That might be another thing. So I have some links to this study here. One of them is this, it was in the American Economic Review, which is one of our flagship journals. And I'll just briefly kind of point out something about these studies. This uses a 1994 law change, and it exploits so-called quasi-experimental variation. So this is stuff that you'll learn about when you take econometrics one day. And they just say that there was some variation in the way rent control was assigned. Why do we care about this? Well, what you're trying to do is get a comparable sample of units, right? So it's not often the case that you can sort of say, here we have units that are assigned rent control, here we have units that aren't, right? They're otherwise identical, but these were rent controlled. That's what you need to estimate the effect. So they use this change in the law that kind of does something like that, randomly assigns otherwise like apartments to rent control or not. And so they do find that, well, people move less when there's rent control, right, by 20%. And they also talk about how the supply of housing fell by 15%, right? How do they do this? Well, they even say something about what typically landlords do. And it's kind of a neat study and a great study design. And economists love these quasi-experiments where you get these things. So here's another one. This is on minimum wage. Right? And this is about what happened when Seattle raised its minimum wage. And again, what they do is they try to get a comparison where they're saying, all right, well, Seattle's different than everything else in Washington, but we want to kind of control for all those differences and get a comparison here. And what they get are results like this. And you can see here what this means is that this negative elasticity suggests that the minimum wage caused a fall in employment. So this is kind of interesting too. Seattle workers matched to counterparts in outlying regions, they have no change in the probability of employment. So people didn't get fired, but they got a lot less hours as a result of the minimum wage. And this, as I was saying, was particularly true for less experienced workers. Less turnover, right? But less hiring, right? Kind of also other aspects of it. Okay, so this is kind of what you have to think about. By the way, I'm not suggesting that you like or dislike, that these policies are all bad. Maybe you like the idea, say, of neighborhood stability, right? People not moving in and out of a neighborhood or changing all the time, and you value that, and that's the reason, say, you have rent control. That all having been said, once you have the policy, you still have this rationing problem, right? Who gets the jobs, who gets the apartments, and how do you decide? So at best, you have we call it means testing, you have some way of figuring out who really needs the apartment, and you give it to them. That's sometimes possible. And the worst case scenario, you might also want to think about, well, who gets the apartments? Your friends, people you like, maybe your family members. Hey, if I have to rent this at a low rate, maybe I'll give it to my nephew, right, my apartment. Or you might even resort to some other means of rationing, and that's how an economist might think about racism, right? Well, I know one way. I can just rule out a whole bunch of people, right, and pick and choose who I want to rent to, right, if there's no sort of market rate. And that's an unfortunate side effect sometimes of market intervention policies. Okay, so I've gone on way too long about, well, actually not way too long. We're in good shape here. We're going to talk a little bit about taxes, and in some ways this is the cleanest way to think about what's really going on when we dip into a market and mess around with it, right? And so there are a couple lessons that emerge from this, right? And it's really kind of a nice way of thinking about all of the things that happen when you intervene in a market. One thing about a tax, if you think about a tax on gasoline or alcohol or cigarettes or whatever, is that you can place it nominally on consumers or you can place it on consumers, right? So you might think about it this way. For every gallon of gasoline, say, that a supplier brings to the gas station, we make them pay a tax, right? The truck pulls up, they put that tube in the ground, and every gallon they pump in there, we make them pay us 15 cents to the government. It's one way to do it. Another way to do it is to just levy it right on the consumer, right? So when you go buy gas and put it in your car, you know, $10 goes in, and then maybe $2 additional goes to the tax authority. So that would difference between producers and consumers. We will see that it makes no difference. Exact same impact. Question?
Isn't that how tariffs work too?
Exactly. So tariffs are a special case. We're going to talk about this after the exam. That's exactly right. And indeed, you can think about all of this through the lens of tariffs, right? I'm sorry, you can think about everything I'm about to say as tariffs as well, with some nuances that we're going to develop after the exam.
So who gets I know in the tariffs, the people who are the shipping point are the people who get charged. But
Okay.
How does that work?
Okay, we're going to see how it works. And by, the question was, how does it work, these taxes? Well, I'm going to show you that it makes no difference whether you might have said, yeah, we should tax those damn oil producers, right? Rather than the consumer. I like that first idea you had, Baker. And I would say it makes no difference as to who winds up paying the tax, right? As you may or may not know, taxes can be passed along, and once again, who bears the tax, the passing along effect, depends on the market, the shapes of supply and demand. So one example of this, we call it the tax wedge in economics. And why is it a wedge? Well, it's because it's wedged between the price sellers get and the price demanders pay. Those two are different when there's a tax. I should say effective price they get and pay. So a $1 tax on a $10 bottle of wine, right? Something like the following might happen. If the market price once again, I say the market price was $10, we need our counterfactual, which is what the market would look like without the tax. So we say, all right, without the tax, the price was $10. When we put the tax in place, well, what happened? A $1 tax, we observe that the price of this bottle of wine rises to $10.60. An economist would then surmise that, all right, well, what's happening here is, well, the price was 10 and it rose, the tax is $1, and the price only rose by 60 cents. The implication is that 10.60 minus $1 is 9.60. That's what producers are walking away with, right? So relative to the $10, producers are now getting 9.60. They're paying, we would say, 40 cents of the tax. Consumers, well, it's a little bit easier. The price was 10, it goes to 10.60. Their price has gone up, and they are therefore paying 60 cents of the tax. That's what and you might wonder how I came up with these numbers. I just invented them for illustrations purposes, but there are some rules and some interesting economics between figuring this out. But, okay, that's one lesson. We can put the tax wherever we want, but who pays it depends upon supply and demand. Another big lesson is that we create deadweight loss with taxes. And thinking about why that happens might even help you understand what I was saying before. So let's talk about the daily, I should have said gasoline, right? Gasoline market in New York State. So here's my market, and we have millions of gallons per day. I have no idea if these numbers are accurate. I made them up, but I tried to make them seem more realistic. Our market without a tax, we see, has 4 a $4 price, 4 million gallons going per day. And of course, I shaded in the areas, but hopefully you're training your mind's eye to look at these diagrams and say, all right, I see the surpluses, right? The surplus here, consumer surplus, 4 to 12, that's 8. This is 4, 8 times 4 is 32, divided by 2 is 16. So you'd say $16 million in surplus a day for consumers. Here, 0 to 4, 4 this way, 4 times 4 is 16, divided by 2 is 8. So we have, in the beginning, we might say we have 16, what did I say, 16, I'll write it down. Producer surplus was 16. And consumer surplus was 8. So if we added those together, we would get 24. Okay, so this is, why did we do this? Because we need a baseline. This is what we're measuring everything relative to. Yes?
Repeat that one more time, I'm sorry. 16,
Okay, so the 16 is the area of the red shaded triangle there, right? You see the base from 4 to 12 is 8. This way is 4. 8 times 4 is 32. Divided by 2 to get the area of the triangle is 16, right? Yeah, it's. By the way, if you ever get a little stuck with the math, I've seen this at every, I teach this class, I've taught, advanced micro theory at the Graduate Center. There's the logic and then there's the mathematics. And you want to be able to keep them separate, right? So what I'm saying is make sure you get the math clear so you can just forget about that and you can think about the logic. So it often helps to think about, if you miss a little step or something, just ask.
So find the area of the surplus or the shortage, you always have to finish off by dividing by 2.
Yes, because that's the area of a triangle, base times height divided by 2. That's where it comes from. In a rectangle, handily enough, as we've seen, base times height, right, is the area. Yeah?
What would the unit be for this area?
Oh, boy. Okay, so this is like my sons who are taking physics in high school. They obsess about units, and we're terrible about this as economists, so you should always ask. But you would say the units here are actually, they have a time element, and you'd say millions of dollars per day, right? Because we have gallons, price per gallon. Okay, so the gallons and the price per gallon, the gallons will cancel. You get price, and then there is a day, right? You should always have a time unit as well. Good question. Okay, tax on consumers. So this is the number you pay at the pump, we'll say. And we're going to make a simple observation here. We're going to say that I have a $3 tax coming in here. We're going to think about exactly what this does intuitively to the demand curve. So you see my demand curve starts at 12, right? And you might say that if I get a gallon of gasoline, right, that person on the far left here, somebody out there would pay up to $12 for a gallon of gasoline. That's their benefit. Well, if we say you now have to pay $3 in tax for every gallon of gasoline that you use, we can just say, okay, well, subtract that right off my willingness to pay, right? Because every time I'm not going to get 12 in benefits, I'm going to get 3. I'm going to get 9 because $3 has to go to a tax. The same is true for this person here, the 2.5 millionth gallon. They would have paid $7, right? But if we add a tax in, they have to give us $3 right off the top. Their willingness to pay falls to 4. So one way of thinking about what this tax does is it just shifts our whole demand curve back by the amount of the tax. And you can see exactly what that means. It's kind of it's a vertical reduction in the y-axis of 3 units. Pretty handy, right? That we can just shift this $3 tax like that. Once we've made that observation, everything else just kind of falls into place, right? We can say, all right, well, let's see. 12, so move that demand curve back by 3. We now see that people, it's like they're paying when they when they buy a gallon of gas, well, the last person is paying $6 effectively to get $3, to get $3 in benefits. So at this point here, we can see that this is where now demand and supply will be equal. And if you think about it, just take a good hard look at this point where my dashed line crosses this blue line. You can see that at this point, producers are getting effectively $3, right? Consumers are paying 6. This distance here is 3, right? The distance between this point and the vertical point above it is 3. So everything kind of adds up. All of the accounting works out at that point. I go to the pump, I pay a $6 price, right? $3 goes into the cash register for the government. $3 goes to the producer, who thinks of that as the price that they receive, right? I pay 6, the government gets 3, the producer gets 3. And indeed, we think about this as our new equilibrium, right? As I've said over here. And you'll notice that the new quantity here is 3 million here. So we think about this as our equilibrium after the tax. Okay, and we can do the usual calculations I'll show you in a second. Do I do this in the? No. We can do the calculations out as we normally would here with a caveat. So we might say that at this price of 3 that producers are getting, their surplus is here. 0, 3, right? 3 here. So we can say that producers now have 3 times 3 divided by 2 is 4.5. Maybe I'll write that down. 4.5. So that's after the tax here, 4.5. Now consumers are paying an effective price of 6. So we can go across here and we could say, all right, well, let's see. 12 minus 6 is 6 times 3, 18. 6 times 3 is 18 divided by 2 is 9. So consumers are paying 9. Or I'm sorry, getting consumer surplus of 9. So we have, maybe I'll keep up the theme of doing this in red. And so you can kind of see what the difference is here. So maybe what I can do, I'm going to try this here. No. Why does that keep happening? Pull it down here so I can point a little bit more easily. We have this area down here as producer surplus. This area up here as consumer surplus. We've left out an area, right? That is this area in the middle here, right? Anybody want to guess where that is or what that becomes? Well, let's see here. The amount of the tax is $3, right? 6 minus 3. The number of units produced, 3 million, right? So if you take the amount of the tax and multiply it by the units bought and sold, you get total tax revenue, right? And that's what happens here is this box becomes tax revenue, right? To the tune of, what did I say? 3 times 3 is 9, right? So here we have 9 plus 9 is 18 plus 4.5 is 22.5. Is that right? 22.5. We add all this up, we get 22.5. Prior to the tax, 16 plus 8 is 24. So when we've done the calculation out, we've accounted for everything but 1.5, I guess, $1 million. What would we call that? You guessed it, deadweight loss, right? And that is this triangle here, right? The deadweight loss. This is people who would have bought gas and suppliers who would have supplied it to mutual advantage, but don't, because they cannot cover the cost of the tax, right? So for example, this person here would have sold you a gallon of gas at $3.50, right? This person of here would have been happy to pay $5 for a gallon of gas, right? The problem is someone has to pay the $3 in tax for that gallon. Let's see, my value at 5 minus 3.5, that means we're gaining $1.5 or $1.50 when we trade, not enough to cover the $3, right? So those units go away. One other little thing I slipped past you is when I added up all of the area, you know, you might say that this is societal welfare gains from exchange before the tax. This is societal welfare gains from trade after the tax. I included the tax revenue in the calculation effectively, right? So I said that we should think about this, maybe this tax revenue collected kind of like a societal benefit or as a gain from trade. Maybe a societal benefit's a better way to think about it. Why would I do that? Well, the supposition is that we can take that revenue and build a school or a library or something, right? You have to raise money somehow. But that having been said, we still create a deadweight loss when we tax. Okay, so that's kind of a lot. I think on the exam, I'm not going to, it's too much to ask you to calculate all the surpluses in this case, but at least you sort of know that you can look at the diagram and see the same sorts of causes and effects there. How am I doing here? Oh, good. So if I could only figure out how to go forward a slide. There we go. So what if we did the same thing to producers, right? Or we flipped it around and said, instead of having you pay the tax as the consumer, we say to the producer, every time you plop a gallon of gasoline into the tank at the gas station, you're going to have to pay $3, right? How does a producer think about this? Well, the producer says, you know what? That's a cost to me. That's as much a cost as pumping the oil out of the ground and refining it into gasoline. All of those things cost money. Well, if you add a $3 tax, that just adds to my cost $3 of every unit produced, right? So I've generated a cost for producers. And as a result, what we can do, because supply measures costs of producing units, just add $3 to that supply curve, in effect shifting it up, right? Meaning, you know, someone out there could have provided a gallon of gas for almost no cost, right? When you make them pay a $3 tax, you've moved their cost to $3, right? Someone out there could have supplied a gallon of gas at a cost of $2. Well, now if you say you pay your production costs, $2, whatever, you now have to pay a $3 tax, boom, you move their costs up to $5, right? So put another way, what happens is you just shift the entire supply curve up by this amount of $3, right? And now, maybe it's even more obvious in this case, we can just think about the intersection of supply and demand in exactly the same way. By adding the tax, we've created a wedge, I'll talk about the wedge in a second, between what producers what producers get and what consumers pay. Now, consumers add the price, right? They sort of think about it as, they charge you a price of $6, they only get $3 back. So once again, the difference between the consumer price and the producer price is $3. You can see here that if we were to calculate out the surplus, well, it would be 3 times 3 is 9. And then for consumers, it would be 12 minus 6 times 3, 18 divided by 2, 4.5 and 9 again. We get, put another way, we get exactly the same bunch of answers that we got before. Regardless, so we might even say this, regardless of where we levy the tax on producers or consumers, the result is the same. And maybe you can think about the geometry of the diagram and contemplate that a little bit. But that's what happens. Exact same set of outcome. Same surpluses, same revenues, same deadweight loss. Now, really what we care about as economists is, whether you want to do the consumer thing or the producer thing, you'll see that the end result is that the price producers get is $3 lower than the price consumers pay, which is $3 higher than what consumers get. This dark arrow here is what we would call the wedge, the difference between the the difference between consumers' prices and producers' prices always winds up being that wedge, right? The amount of the tax, wherever we place it. Now, I'll show you, there's a very quick and simple way of doing this, I'll show you in a second, where you don't even have to think about shifting the curves and all that stuff, and you just call it wedging the wedge in there. Well, that's what I don't think that's in the book, I call it that. But once we've sort of gotten past that intellectual hurdle, we can then think about who actually pays the tax, right? And you can see here, the way we would assess that is we would say, well, let's see. The price was $4. For producers, it's now $3, right? Let's see. So their price has gone down by $1. The tax was $3. So 1 divided by 3 would suggest that producers pay 1/3 of the tax, right? Consumers, on the other hand, well, their price was 4, and now it's gone up to 6, right? So let's see. Their price has increased by 2. The tax was 3. 2 divided by 3 is 66.7, right? 2/3 of the tax. The way we would say this in terms of economics is that consumers pay 2/3 of the tax and producers pay 1/3 of the tax. And this has nothing to do with whether we've taxed the oil going into the tank or whether we've taxed people buying it at the pump, and just has to do with the mechanics of supply and demand. Okay, so here's the diagram. Maybe I should have put this a little bit closer to the beginning, but this is the punchline diagram from all of this. And by the way, I'm going to do 2 things after I do this. I'm going to show you a nice and simple way of figuring out what happens with the tax, and also some principles underlying how to tax if you must, right? But anyways, so here's all the calculations, right? We would say blue, producer surplus after the tax. Red, consumer surplus after the tax. Green, tax revenue, right? The amount of the tax times the units sold. Gray, deadweight loss from taxation, right? And, for want of time, I'm not going to calculate out all the, hopefully you can just sit there. I mean, this is a well-constructed example. You can probably calculate all these out in your head. So for example, and I'm kind of trying to train you to do this. Let's see, I'm going to do the deadweight loss. 6 minus 3 is 3. 3 times 4 minus 3 is 1. 3 times 1 is 3, divided by 2 is 1.5. Okay, and that squares with see, we always have a way of checking. 24 minus 22.5 also gives you 1.5, right? So the surplus before minus the total surpluses after. I'm very proud of this diagram. I think these things have gotten easier to draw with AI, so yeah, go ahead.
So, I just caught what you said. You said that it was total surplus minus total shortage. That's what the deadweight really.
Let me say, no, the deadweight loss is total surplus without any taxes, right? At the original market equilibrium, minus total surplus at the new equilibrium with the tax. So it's consumer plus producer surplus before, minus consumer surplus plus producer surplus plus tax revenue after. That's the accounting of it here. Let's see if I can show you a couple tricks of the trade here, how this works out graphically. I was sort of wondering if people would leave when I was behind the board. Okay, so one thing you can do is you can do all of this using a little bit of geometry. I think the blue is the best here. And you can kind of say, all right, well, let's see here. here's quantity, price, demand, supply, right? Here's our initial market equilibrium, P and Q. We always start there before we do anything. And let's think about a tax, right? Now, what is a tax here? Well, a tax, as far as we're concerned, is a dollar unit, so it's just some, we can represent it as some distance here, right? So maybe I'll call this my tax, right? This line here is my tax. Now what we're trying to do, we could shift the curve back, the demand curve back by that amount. We could shift the supply curve up by that amount. But another thing we could do is we can just say, forget about that, we'll cut to the chase here. We're going to take this black line and we're just going to wedge it vertically between demand and supply, right? And so, let's see, that might be at some point like this, right? So, if you can sort of imagine that. And this will describe for me the new equilibrium, just wedging the tax in there. So this is often useful, so you think about doing this on an exam, you're kind of just starting here and then drifting backwards until you find the point at which supply and demand are 3 units apart, right? It's kind of the same idea in reverse. Just wedging the tax in there, and then, you can say, okay, well, what's this point? What's this point? Here we have our producer surplus. Here we have our deadweight loss. Here we have our tax revenue, right? And here we have our consumer surplus. I know that's not great. But this tax wedge is actually kind of a neat way to think about it. It's kind of weird. I was holding this marker pointed to myself. It's kind of frightening with this. But one of the neat things about this is that you can then kind of think about policy experiments and stuff about tax incidence. So for example, one of the rules of taxation is that the inelastic, right, or steep, if I want to put it more simply, the steep side of the market winds up bearing a tax, more of the tax, in terms of our incidence analysis. So, quick little diagram here. I'll draw. Let's suppose I draw a steep demand curve and a flattish supply curve. So there's supply, there's demand, right? And now let's suppose I have a tax wedge just hanging around over there. So maybe I want to just kind of see what happens if I put that tax wedge in this market. Well, once again, usually you want to, just to be clear here, denote the original equilibrium. If we wedge that in there, maybe it looks something like this. So the vertical distance is like that. That looks about right. You can see what happens in this scenario. Because demand is steep, put another way, because people are kind of willing to pay whatever to get a fixed amount of units, when we do the incidence out, the price for producers falls only a little bit. The price for consumers rises a lot, right? So the idea here is that if the demand curve is steep, consumers wind up bearing a bunch of the tax, or put another way, the producer passes on a lot of the tax to the consumer. The other thing you might notice is that when both curves are steep, deadweight losses are small. Right? So the way you might see this, how am I doing on the, let me just check the time here. Perfect. Okay. The way you might do this is you might say, all right, well, let's see here. I'm going to draw demand and supply. I should be using this marker all the time, I think, right? It's going to I'll draw this steep. Here's supply, here's demand, quantity and price. Now, if you take a tax wedge, just take it like that. Here's my starting price and my ending price. Well, the usual, my starting quantity and price. Wedge it in there, and you can see, maybe you get something like that. The incidence might work out however, but you can also see that this triangle, when these curves are really steep, becomes quite small. And that kind of makes sense. It says that what people do in this sort of market is not very sensitive to price, so if you tax it, right, it doesn't distort the quantities that much. So people often take this to be, I think it's called the Ramsey rule. You can take a class in public finance and learn all about these things if you find it interesting. Which says that you should tax relatively inelastic goods, supply and demand, right? Of course, that's a little bit, uncomfortable. You think about goods that people demand inelastically. Maybe some, off the top of my head, insulin. You really want to be taxing that, to minimize deadweight loss distortions. So, you got to be careful when you think about these things. And that might be a good common lesson for us to remember, is that not everything important is on this graph. And so I'm going to take 90 seconds to just sort of say this, because for about a week and a half now we'll be preoccupied with exam stuff. I've spent hopefully 2 classes now, 2 to 3 classes maybe, making a case for you that intervening in markets is bad, right? That if you mess around with the market, you invariably create deadweight loss. You create additional problems, rationing, right? All sorts of things. Evidence even suggests this. So you might now say, well, okay, Baker's made the standard free market case here, I guess. But what we're going to do now is start to think about all the ways in which the world can behave differently than what we're suggesting here, right? Or all the ways in which we can add in things that are important that are not on the diagram, right? We haven't talked about monopoly power. We haven't talked about the environment. We haven't talked about education or poverty or inequality, any of these things. What happens when we want to think about these things? Well, it turns out a lot of what I'm suggesting might not work the way it does, so maybe I'll spend a couple weeks telling you about market failures, why we shouldn't trust market outcomes. But then I'm going to come in over the top and tell you about, if you think the market is failing, maybe the solution is more markets, right? Anyways, so look at that practice stuff. Next time we'll reconvene and we'll talk a little bit about, we'll do review, and then we'll have our exam. It'll be fine, we'll do great.